Okay, guys, so I'm going to look at a couple of different graphs today. This is just how we're going to graph these polynomial functions. I've already given you a little bit of information on all these, so hopefully it won't be too hard to understand. But let's look at these. All right, so it says f of x when x is equal to x squared, g of x is equal to x to the fourth, and f of x when x is the sixth power. All right, we'll look at that one first. Over here, x squared, told you it's always going to be a parabola. All right, x to the fourth is a little bit narrower of a parabola. X to the sixth ends up being even narrower at the top, but look how it's fatter at the base of it at 0. Okay, that's because it's growing exponentially faster, so it's going to get steeper on the way up. Okay, may take it a little bit to get going, but once it gets bigger, the number gets bigger. It's going to exponentially, what we call exponentially grow. It's going to get steeper on the way up. So may get fat, we're getting bigger numbers. Now we're jumping up big time here. Now, if we look at the other one, it says look at x to the third, x to the fifth, and x to the seventh. If we look at those, let me go ahead and clear these off. I told you odd exponents are they're in behavior. How they end, they're going to be in opposite direction. Evens, they're going in the same direction. They're both positive. Odds are going to go in opposite direction. And same thing. It may be wider at the base, but it's getting exponentially higher because it's a higher degree. It's going to be steeper in its end behavior. Okay. So that's all the first classwork thing and example I wanted you to look at. Okay. So let's go to page 2. And it says, exercise 1, consider the following functions. F of x is equal to 2x to the fourth plus x cubed minus x squared plus 5x plus 2 with a mixture of odd and even degree terms. Predict whether its end behavior will be like the function of the opening exercise where they are the even degrees, or like the example 1 where they're the odd degrees. Graph the function f using a graphing utility to check your prediction. So let's see if I can do that. I don't think I can copy and paste this. Nope. Okay. So, well, my prediction is going to be, it's going to be like at the opening exercise because the highest degree is to the fourth, and that is an even. So let me go over here and graph that. And that's going to be, said f of x is equal to 2x to the fourth plus x cubed minus x squared plus 5x plus 3. Okay, so for you, you need to be doing this on your graphing calculators. Okay, you definitely need to be doing this on your graphing calculators, making sure you're able to do these. All right. So let me take these off and we can look at it a little bit better. All right, that's to the fourth, right? If I throw x to the fourth up here, now it looks a little bit different. This 2 coefficient is going to make that look different. Okay, but we can tell that it is definitely a parabola. The end results are going in the exact same direction. go to consider the following function. It's a mixture of odd. Okay, well, same thing. This has a x to the 5th, so it's going to look like example 1, right? So let's look at it just to be sure. We got alpha of x is equal to 2x to the 5th minus x to the 4th. Once again, you need to be typing this into your calculators, making sure you're able to get these graphs and not just simply relying on Mr. Anderson's, because whenever you start doing this on your own, I'm not going to be able to come over and type it into your calculator on the test to show you how to do it, and probably won't know how to because every calculator is different. Okay, so here we're going to have to scroll up, zoom out a little bit, move up a little bit, now zoom back in. Okay, once again, x to the 5th. If we go up here and click on it, we can see how the end behaviors are going in opposite directions. So to the negative, it's going to the negative. To the positive, it's going to the positive. And we'll go over that in a little bit as far as how to talk about end behaviors. Okay. C, thinking back on the discussion of x-intercepts and graphs of polynomial functions from the previous lesson, sketch a graph of the even degree polynomial functions that has no x-intercepts. So if we were to do that, we would have, that is our x-intercept. Okay. If it's an even degree, it's going to look like a parabola, right? So it may be something like this, and the other one may come down here and do something like this. Okay. Similarly, sketch a graph of an odd degree with no x-intercepts. How are you going to be able to do it with no x-intercepts? You're not going to be able to, right? Because it's going to be going in opposite directions. So if it was down here, it's going to be going up there. Because over here, guess what? That's going to keep coming down and hit it there. So odd degrees are always going to have an x-intercept. Okay. Center of Transport Analysis studies all aspects of transportation in the United States, from energy and environment concerns to safety and security challenges. A 1994 study compiled the following data of the fuel economy in miles per gallon of a car or light truck at various speeds measured in miles per gallon or miles per hour. The data are compiled in the table below. Okay, it says plot the data using a graphing utility, which variable is the independent variable. Okay. Normally, when you're talking about independent variables, whenever you see a graph like this, this is going to be your x and this is going to be your y. So your x is your independent. Okay. Your fuel economy depends on your speed. That's how you know that that's going to be your dependent variable. Okay, so this would be speed, which just tells you that when you're putting that in as maybe as coordinates, you would put the x 15, 24.4. Okay, so what we're going to have to do is on your calculator, you need to be able to plug in these points, these data, and make a graph. I'm going to pause the recording for a second and let y'all work on that. Okay, here's what that would look like. And let me make a, oh, how do I do that? Yeah, I'm gonna make a line out of that and make it a little bit easier to see. Okay. No, what do I do? What I just did. There we go. Okay. Now it is a line and we can see it. Now, what does this remind you of? This data can be modeled by a polynomial function. What type of polynomial function? To what degree, in other words? Well, we know it's going to be an even degree. How do we know that it's going to be an even degree? Because it has the same end behavior going in the exact same direction. Okay. And the way we would talk about this is we would say as the function approaches negative, talking about x, the end behavior is going to be negative. As the end behavior approaches positive infinity, then the end behavior approaches negative infinity because it's also going down. Okay. Let me go back here. Okay. So I just want to make sure I'm sharing the right screen here. Okay. All right. So it says, is the leading coefficient of the polynomial that can be used to model this data positive or negative? Okay. Well, we would say it could be negative because it approaches infinity and negative infinity, and it is negative. That's what we're talking about. So what we would say is, since it is approaching negative infinities, then it could be negative. There's two possible reasons the data might have the shape that it does. Well, fuel economy depends on speed. If you're going 5 miles an hour, you're not going to get very good fuel economy. As also, if you're going 100 miles an hour, you're not going to be getting very good fuel economy. Okay, certain cars are really made to have like the precise speed to get you the best fuel economy. And we would say this one would be in between 50 and 55 degrees, right? So that's the answers. So it improves up to a certain speed and then it drops below a certain speed. Okay. Let's see if there's anything else on here that we need to look at. Okay, yeah. So here we go. This is just some more terminology. We may have a quiz here in a couple of days on all this terminology that we're learning, okay?